Okay, so we come now to a topic this morning, are we slaves to our genes? But I think some people might find a little bit controversial. In fact, before getting into it, let me just thank one of our staff members who left some years ago, and that is Nell Whiteway, who did quite a bit of the earlier research. She was here on our staff for 3 years and did a fantastic job, really, in researching this general area. This was in preparation for the Gifford lectures that I gave some years ago, which then became a book and so forth. So I want to acknowledge Nell. I want to also say, as I'm mentioning, some people do find this topic a little bit controversial, and I think the reason can be quite varied. Obviously, the whole sort of field of behavioral genetics has a very sad history in the history of eugenics. I'll give you an example in just a moment of that. So that's maybe one reason. Other people think it has racist overtones, that sort of thing. Other people think that, well, they listen to some of the exaggerated claims of scientists, and they do exaggerate sometimes in this field, and that's not very helpful. So all I just want to say this morning is I think we need to come to this topic calmly, rationally, and keeping an eye on the scientific literature, and realizing that there are many unanswered questions as well. Okay, so that's where I want to go this morning. So here's the roadmap for this lecture. I just want to reflect a little bit about genetic determinism, give some of the background to that. I want to then focus very much on developmental biology, which is a really key area for this whole field. Then we'll think specifically a little bit about behavioral genetics, which is a huge field in itself. Then we'll think about determinism and free will, and then we'll do a little bit of theology. That's all we've got to do in the next 45 minutes, So just relax, it'll all be fine at the end. But let's start just by looking at a rather horrendous quote from actually a very well-respected scientist. He was Madison Grant, president of the New York Zoological Society. We're talking about 1916, just over a century ago. Very respected man. This is what he said. Mistaken regard for what are believed to be divine laws and a sentimental belief in the sanctity of human life tend to prevent both the elimination of defective infants and the sterilization of such adults as are themselves of no value to the community. The laws of nature require the obliteration of the unfit, and human life is valuable only when it is of use to the community or race, close quote. Horrible, isn't it? I can see all your hearts going, oh, how could anybody say that? That's only just over a century ago. And of course, the German Third Reich, as you probably know, borrowed a lot of its legislation on sterilization back in the 1930s from California. So eugenics was big in America, compulsory sterilization big. California was the leading state, and the Nazis borrowed some of their legislation from there. The whole history of eugenics is really amazing. We can't pause on it now, but I think we can learn a lot. We can learn a lot from that terrible, terrible history. And of course, as we know, the most extreme applications were in the gas ovens of Auschwitz and Buchenwald and so forth. So a terrible history. And therefore, I always feel, talking about this topic, and that's in the back of people's minds, let's just make sure that we're very far away from that. And of course, I think today, generally, such attitudes are viewed with great horror, and rightly so. But at the same time, as genetic determinism was sort of ushered out the back door, hopefully many decades ago, at the same time, it still seems to be coming back in again through the front door. It's strange, isn't it, how these things work? And I think this sort of determinism we have today is more of a kind of insidious, cultural, creeping determinism that is not quite so overt. And sometimes it's absorbed from the media, but here's a quote from a recent news feature in Nature. And there they record, the writer records that an increasing number of studies suggest that biology can exert a significant influence on political beliefs and behaviors. Genes could exert a pull on attitudes concerning topics such as abortion, immigration, the death penalty, and pacifism. And then the writer goes on to say, he goes on to quote actually from John Hibbing, who's in the University of Nebraska-Lincoln, saying that it is difficult to change someone's mind about political issues because their reactions are rooted in their physiology. So here we have a picture, don't we, of we have the genes over here somehow controlling our minds like some great power, so in such a way we can't even change our minds. And the language also is strongly dualistic, isn't it? In a sense, we've got genetics over there, and we've got our choices over here. Somehow they're split. And that's in one of the leading science journals in the world. Okay. So that's what I mean when we talk about this insidious sort of language coming in to some of people's thinking. So does it really matter what people think about this particular issue? Does it matter if people think that their decisions are determined by their genetic endowment? What's at stake, really? And I think, clearly there's a lot at stake here because it's our human freedom. How can we be held to account for our actions if people are going to blame their genetic endowment for their actions that they took? What happens to our justice system? What happens to the choices that give value to relationships, to our concept of love, to our religious choices and values and so forth? And I think that sense of moral responsibility is one of the deep glues that keep our societies together. And if you lose that glue, then you have some big problems coming up. Now, of course, everybody today knows that genes and environment sort of collaborate or compete in some way to bring about the sort of people that we are. Everybody knows that we're the product of this complex gene-environment interaction. And I think it's there that we have a sort of problem, really, because that creates a kind of what I call a dichotomous. I know that some people might not be familiar with the sort of more technical words, but I mean simply the separation, the idea of two things somehow competing with each other. It somehow generates that sort of idea sometimes. So we end up with a kind of fragmented understanding of human personhood where there's a struggle going on. One side you've got the genes over here, and then over there you've got your environment, and somehow they might be kind of fighting together, tugging in different directions, as if the human personality was some sort of site of psychological warfare. Now, as far as English is concerned, that dichotomous language really goes back to somebody called John Galton. This is Darwin's first cousin. He first introduced the terminology of nature and nurture, again, dichotomous language, in his book of Men of Science, Nature and Nurture, 1874. And as Galton himself pointed out, this phrase nature and nurture is a convenient jingle of words. And he emphasized that no carefulness of nurture, that is to say, the environment, can overcome the evil tendencies of an intrinsically bad physique, weak brain, or brutal disposition. He was a Victorian, okay? And that's the sort of language they used in those days. Okay, but the point about Galton really is that nature is always dominant in his writings. He always thought that your inheritance, and of course he came from a very good inheritance, and so he was reflecting the social structure of his time. But it's amazing how nature and nurture is still such familiar language, isn't it? Right up to present day. Here you are, do this little experiment. Put nature plus nurture into Amazon, okay? Little empirical experiment here. See what it pulls out, okay? And here you find books with titles such as Nature or Nurture, Nature and Nurture, The Nurture of Nature, Nurture by Nature, Nurture through Nature, The Nurture-Nature Debates Bridging the Gap, Nature or Nurture, The Great Brain Debate, and so forth and so on. Can you see how framing is so powerful, isn't it? 1874, a phrase comes into being. Today in Amazon, you have a powerful framing many of these books. Now, I haven't read all these books. I read some are good, I'm not slamming the books there. I'm just simply saying, is that really a helpful framework for thinking about the topic this morning? And I want to say, no, I don't think it is. Right. So, now, here's a different kind of a framework, which is not nearly so jingly. I'm sorry about that. Okay. But you can say dicey, if you like. And it stands for 4 words, which I want to use today as pegs to hang different ideas on. Okay. Developmental, integrated, complementary, interactionism. Dicey. Okay. I said it wasn't so jingly, right? But it takes us away from this dichotomous language, and that's why I think it's a sort of valuable acronym to center our thoughts around this morning. Now, development is clearly the key. Of course, development starts at conception. I'm talking about human development. It starts at conception, and it continues all the way to death. We are always developing. We're always learning, I hope. We're always developing biologically as well. And it's a very complex process, and all the different components are integrated together. They're not fragmented, they're integrated together. That's what life is about, integrated components. And there's a continual interaction between all the different components of the DNA, the genomic system, DNA, the microenvironments, what we can call them, the macroenvironments, and so forth. By microenvironment, what I mean here is all the immediate molecular machinery surrounding the DNA and the cells and all that kind of thing. Right? By macroenvironment, I mean the interaction of the organism, us in this case, with our wider environment. Okay, so it's simply to make that sort of distinction. And there are many complementary processes happening in parallel. I mean, that's why in our departments of medicine, we just need layers and layers and layers of specializations, as I know some here represent, because we have to address this complex organism, humans, from many, many different perspectives and so forth. And I think those complementary processes can sort of undermine the understanding, undermine the misapprehension that genes are somehow controlling us, or there's a gene for aggression or something like that. Start getting away from that kind of language. And in fact, when you look at what we inherit from our mothers and our fathers, the mothers, I mean, we don't inherit naked DNA. Okay? Naked DNA can do nothing. And so if you look at the mother's egg at fertilization, it contains at least 3,000 proteins. It contains at least 7,500 different types of messenger RNA, another important molecule in the story. It contains thousands of small regulatory non-coding RNA molecules. I mean, it's a very, very complex system. We are inheriting a computer, okay, or something like a hard disk in the egg, okay. It's not naked DNA. DNA by itself can do nothing. So by itself, I often say that DNA would be as useless as a CD with a bit of software on without any computer, to run the software on, or something like that anyway. Okay, so that's an important point. And if you look now at where the infant brain is, how the infant brain is developing, I mean, that's an amazing story in itself. The infant brain is not a sort of miniature version of the adult brain, but rather it's a self-organizing system that only self-assembles correctly if the right inputs are available at the right time. Now, this is where the infant brain has got to get to. This is what's in our adult brains this morning, where each neuron receives, in our brains I'm talking about here, receives on average around 5,000 synaptic connections, that's linkages with the other neurons. The range is pretty broad. Actually, some neurons connect up to other neurons by as many as 200,000 synapses. Now, we have got around 100 billion neurons in our brains, plus or minus a few, okay? And so we've got a staggering 500 trillion synapses, roughly, in our brains this morning. That's 5 times 10 to the 14. So we have the most complex organ in the known complex organ in the universe that we know about in our brains, between our ears this morning. Isn't that amazing? I mean, that should really fill us, I think, with a sense of wonder and awe. And of course, if you go back now to the fetal brain, that's where the fetal brain has got to get to. Okay. And in fact, twice as many brain cells are generated as that in the developing fetal brain. About half of them are pruned away during development. And so that is another amazing aspect of the whole process. I mean, it's a huge topic, and we don't have time to look into it now. But it's just worth remembering that it's this synaptic architecture which is created mostly actually just postnatally, a little bit prenatally, but a lot of it is postnatal. So if you look at the increase in synaptic density in the newborn brain, this is sort of what you see. These are looking at all the connections between the different neurons, brain cells. And the average weight of the human brain actually triples during the first year of life, from about 300 grams up to 900 grams. That's not because of more and more cells being made. That's because of all this incredible architecture being created. Okay. So it's a self-assembling system, but it's very dependent on certain critical inputs that have to happen at the right moment. And as you probably know, if babies don't get certain inputs at the right moment, then there can be some very serious consequences. For example, if a baby is blind from birth, then the visual cortex at the back here doesn't develop normally. You can get permanent visual impairment, unless that's corrected in some way. Children born with congenital cataracts in both eyes have these large deficits in motion processing, how to move around and interpret your environment. But children who have cataracts from 6 to 12 months don't have that sort of defect. In other words, there are certain windows of opportunity, if you like, for the developing brain, which are really important. And so, as we say in this field, the brain has considerable plasticity. That is to say, it's developing, it's changing. And those changes, of course, continue right up into the, well, we've got people here who give me a more accurate view on this, but probably not the early 20s. And of course, in some ways, we are changing our brain. I'm actually changing your brain as I speak to you this morning. Don't worry. Okay, it's all going to be good. But so we have this continual operation of neuronal change at the synaptic level going on and so forth. And I think this provides a very useful illustration of the way in which the genomic information provides this critical resource, which is then integrated together with environmental inputs to build the human, in this case, the self-assembling, self-organizing human brain. It's an amazing, amazing system, really wonderful. And as I say, if these critical environmental inputs are not there at the right moment, then the brain is not going to self-assemble correctly. It's also good to remember that our genes are constantly being, they're not being switched on and off so much as being dimmed and amplified and so forth. Think about a dimmer switch here. And this happens by a number of processes, but particularly by what is called epigenetics. So epigenetics refers to the chemical modifications of the DNA itself or to the proteins surrounding the DNA, which actually regulate how genes are expressed, we call it. That is to say, think of the dimmer switch here. We could turn the lights down a little bit or we can turn them up. That process is going on all the time through environmental inputs, which are regulating the epigenetic modifications of the genome and controlling that and so forth. So if you like, if you want to think of the DNA as the hardware, then the epigenetics is more like the software. Analogy is not perfect, but maybe it might be helpful and so forth. And so right here, sitting in this room, if you've had your breakfast, then there will be epigenetic changes going on as you metabolize your food and so on. That's happening all the time as we sit there. And thankfully, we don't have to think about it. I'm so relieved about that. Okay. And if you fasted this morning, then there are other kinds of epigenetic changes taking place. Okay. So I hope you can see, just in this very brief sort of introduction, the way that DICE, developmental, integrated, complementary interaction, it bypasses nature or nurture. We don't have a dichotomous system. We have a complex biological system where all the components are really important. And so if you think about it, when it comes to any major characteristics of our humanity, our personality, maybe there are sort of levels of aggression, naturally, which we've inherited from our backgrounds, some of our intelligence, certainly true, all these things, what I like to say is 100% of this phenotype. The phenotype is the appearance, the structure, the behavior of any organism. 100% of the phenotype of any complex organism involves genetics, right? 100% involves the environment. Okay, they're all involved all the time in development, and that's why we're here, right? So that's pretty important. I was fascinated, by the way, there were a couple of books that came out last year, 2018, both called Blueprint. This is really funny. Okay, so the one on your left there by Robert Plomin. Robert Plomin is at the Institute of Psychiatry here in the UK, where I did my PhD, and he is one of the leading international voices in the whole field of behavioral genetics from the perspective of DNA, how DNA makes us who we are, right? DNA has the upper story, it's the really, it's the real controller. At the same time, here's another book by Lucy Maddox, who works a lot with children, Blueprint, How Our Childhood Makes Us Who We Are. Okay, so which is true? Well, I want to say both. That's the point, both, So we can tell the story from the perspective of the genome. We can tell the story from the perspective of our childhood experiences and so forth. And they're all in there. They're all in there, and we have to take account of them all. And the key thing is not just to say one is the blueprint, which I'm afraid this one does rather on the left. This is a little more balanced on the right, frankly. And, we just have to realize there are lots and lots of components here going on. Right. Now, I know that thinking about the development of a complex organism like humans this early in the morning is really a complex sort of thing to do. Right. So I hope you'll forgive me at this moment if we just look at a black forest chocolate cake. A little simpler. Or is it? Or is it? I love chocolate cakes, okay, and this is a great recipe. I got this recipe off the web, so I'm sure it must be true, okay. So, most of this cake is flour, right? 50%, no flour, no cake. Less than 1% is baking powder, so definitely no baking powder, no cake, right. Around 8% is chocolate powder, that's quite a lot actually. No powder, no chocolate cake. If you don't have the correct heat in the oven, no cake, definitely, something else. So you see where we're going here. So the cake is the product of a complex developmental process that can be changed hugely by the environment as the development is going on, especially in the oven. But if you take the final product, it would be odd, it would be impossible actually, to assign proportionality to the different components and say, therefore, only 1% is baking powder, therefore, it's not really very important. No, you couldn't do that, could you? And so here we've got what we call an emergent phenomena. Cakeness is an emergent phenomena. You cannot take your cake back to original components. Right? There's a lot of philosophy in black forest cake. Right? Okay, so because all those components have been chemically transformed. Okay, the baking powder is no longer present in the final cake, thankfully. It wouldn't taste very nice. It's been chemically transformed. And so this cake has emergent properties, which we described and taste in the form of a black forest cake. Right, just a sort of simple example, but multiply that up a few billion times and that's human development. Okay, let's move a little bit to the field of human behavioral genetics. How does that impact on our questions concerning genetic determinism? It's a huge field. It's very dependent upon twins, adoption studies, all those sort of things. We don't really have time to get into the detail. But I just want to flag out a couple of linguistic points here which are really important. If you look into the field of behavioral genetics, you'll find it talks a lot about heritability. And you've probably read, the heritability of IQ is 50% or whatever, that sort of thing. Okay. And a lot of people are confused by this term, and I don't blame them, because traditionally heritability is a synonym for inheritance, and it's still used as a synonym for inheritance. But in the field of behavioral genetics, it has a very technical meaning. Okay. It's the proportion of the variance in a trait in a specified population that can be ascribed to genetic variation. Okay? It's a statistical construct. It's about a population. It's not about inheritance. Okay. So just to give an example of that, to make a vivid point, if you have a population under study which is 1,000 people with good eyesight, then the heritability of sightedness in that population is going to be 0 because there is no variation. But I now introduce into our population one-sighted person, and now we have a positive heritability in that population. Why? Because there is now some variation. Okay. And I hope that sort of helps you. It's difficult to get your head around it because it is also used as a synonym for inheritance. So in the context of genetic determinism, so what particularly are the outputs from the field of behavioral genetics that might be relevant for us this morning? Well, first, we do have Mendelian single gene traits. By Mendelian, we simply mean good old Mendel's laws and the way that inheritance happens in families and so forth. And there are some examples of those that have single gene defects that have dramatic effects on behavior. And I'm just going to give you a famous example from this Dutch family, actually described way back in 1993 by a geneticist called Han Brunner, and he described a family of 14 males spread over 4 generations of a Dutch family who were characterized by this mild intellectual disability. They also had outbursts of anger, including strong aggression, which resulted in some cases of arson, rape, exhibitionism. They got in trouble with the police, things like that. Now, each one of those males had a total lack of an enzyme. It's called monoamine oxidase A. Don't worry about the name, but the point is that that enzyme is really important in regulating neurotransmitter levels in our brains, right? The females are fine. And if you look at that, family history, it's got the classic picture of an X-linked gene, right? And it is monoamine oxidase is coded by a gene which is X-linked. That means to say it's transported through the generations, conveyed, inherited through the generations through the females, but the females got two X chromosomes, so they've got a backup, so they've got plenty of monoamine oxidase. We males have only got one X, XY chromosomes, and therefore we don't have any. In this case, they didn't have any, right? And so there's been a lot of studies on that particular family and so forth, and the condition is now known as Brunner's syndrome. For many years, almost decades actually, people were looking around, for another example, and they didn't find one until they discovered a French family in 2014, not quite so dramatic, but a big reduction in monoamine oxidase, and then there's an Australian family in 2015. And so it's an ongoing study. So that's a very dramatic example. There are examples like that. They are rare. These are very rare, okay, but they're there. In contrast, the vast majority of behavioral variation within individuals that display positive heritability values is polygenic. Many, many, many genes involved, okay. And this could be, the kind of variation that we find in human populations with respect to psychiatric disorders, to schizophrenia, to autism, things like that. Or it could refer to the variation characterized by positive heritability with reference to personality changes. They have a positive heritability to addictive personalities, to alcoholism, and there's a whole range there of behavioral conditions, behavioral practices, whatever, which have a positive heritability. And over the past few years, there's been a technique called genome-wide association studies, which seek to pin down the genetic variants that contribute to the heritability in the population, which helps to explain some of that variation, not the individual, the variation in the population. And what basically the take-home message is simple. The take-home message is that each genetic variant contributes a tiny proportion of the variation in that population, less than 0.01%, something 0.1%. And there are hundreds, some cases thousands. And as the population study gets bigger and bigger, and the technology gets cheaper to do this, though the numbers of genetic variants contributing to something like educational attainment, and there's been some recent papers, hundreds and hundreds of variants and so on, and that's the finding. Okay, so that's very different, isn't it, from that? That's very unusual. That is much okay. So we're talking about polygenics here, and another sort of phraseology here, which you might find useful to know about, is the polygenic score now, which has become popular in the past few years. People have said, well, if we add up all the variants, we can sort of give people a kind of a score. It's a probabilistic score. So what you do is you get all the heritability values contributed by hundreds of thousands of genome variants in the genome and so forth. And then you generate this sort of probabilistic score, which is probabilistic. Okay? It's simply a case of a predisposition to perhaps develop type 2 diabetes, or predisposition to have a certain type of trait. Okay? So that's another very common language now in the behavioral genetics literature. Right, so we better move on and get to what we really are talking about here in terms of determinism. Determinism, of course, has many different definitions, and philosophers tend to define determinism in a slightly different way from what I'm going to do here. But this is convenient for biologists. Hard genetic determinism, the thesis that given our particular genomes, our lives are not really up to us and are constrained to follow one particular future. Right. We can also then define a sort of soft genetic determinism, the thesis that given our particular genomes, our lives are more likely to follow one particular future. You might say that's not really determinism at all, okay? But we'll stick it in there anyway, okay? And so, in practice, of course, there's a lot of variations across the spectrum. The reason I keep putting up spectrums here, as you'll see, is simply there's a big range here, okay, between those two kind of definitions, right? Do genes cause people to play basketball? Okay, So, this is a way of thinking about it, isn't it? So if you're tall, being tall, by the way, there are hundreds of genetic variants involved in being tall, it's probably more likely that you'll play basketball. These two guys, I can't remember which team it is now, some people might know, they're from the same American basketball team, by the way. And this guy on the right looks a bit short, he's not that short really, but he doesn't have the same genetic environment, but he still chose to play basketball, okay? And so you can be short and play basketball, you choose to do it. And lots of tall people actually choose not to play basketball, right? Okay, so it doesn't determine, right? It's not determining what you're going to do. And of course that does bring us then to this very complex topic of free will, doesn't it? So, which of course we're going to solve in the next 2 minutes, okay? And I just want to point out a couple of points here, and obviously this is a topic that's been keeping philosophers going for millennia. So I just want to give you a little sketch here of a framework which I think could be just a little bit helpful in this discussion for us today. I think we have to start with free will as a lived experience, right? So hopefully you exercise your free will in coming to this course this summer. Did anybody get forced by police state maybe to come in? No. Okay. In other words, we all have that experience, and the sociologists have done reviews of every single population in the world they can find, and every single population of humans in the world experience free will, right? So it's not it is something we all share in common. And I hope that we didn't say that my neurons made me do it when I came here. They didn't make you do it, and so forth. So you could have chosen otherwise. So that's a very important fact, I think. And I won't go further and say that if somebody doesn't have that experience, genuinely doesn't experience it, then they should seek psychiatric help. They will be a danger to themselves and a danger to others, right? So that's really important too, and there are cases like that. Now, so I want to say really from a biological perspective, I'm a biologist, not a philosopher, okay, so I'm afraid I come from that direction. So I would say from a biological perspective, free will is simply a Darwinian trait which all adult humans in good health display in the same kind of way that generally they have 2 arms and 2 legs and 2 eyes most of the time, that sort of thing. And so I think it's just a definition of what being a human is about. It's one of our characteristics. There are not many that all social anthropologists agree on. Religion is one, and pretty much every population in the world has some sort of religion, pretty much. And free will is another. The definition of free will, the ability to intentionally choose between courses of action in ways that make us responsible for what we do. All right, so that's where I want to go with that. Now, our brains, we're going to move more on to the brain later on, actually. I don't want to spend much time on the brain, because I know we're going to have more on that shortly, I think. But just in this context, to point out that often our brains are seen as functioning on 2 levels. So system 1 is automatic, it's unconscious. System 2 is deliberate, slow, and conscious. So the discussion about free will really belongs to the second one, that slow meditation, thinking about what I should do, that sort of process. And so free will is exercised by persons who take into account their beliefs, their desires, their emotions, and so on. And from these, they choose which course of action to follow. But differential genetic variation, then, how does that work? Well, it may enter into the process of making different choices by affecting our beliefs, our desires, our emotions. It may have some predisposition effect. I'm very tall, I could be a good basketball player, right? So, and therefore, I think I will be. And I go in to do that as my preferred sport. But I think the key thing here is that it's human agents who allow beliefs, desires, and emotions to become effective for action when we choose to follow one course of action over another. So that's one way of sort of thinking about it. Free will belongs to intentionality, is particularly important in our free will discussion. So the free will experience, I would want to say, is on a spectrum. It varies all the way from the left of the screen there. It's a lovely sunny day. I feel totally in control of my life. I'm on vacation. All that wonderful sense of freedom, which I don't think we have very often, actually. But I think most of our time we're in the middle there, okay? Yeah, we're constrained by all kinds of things. We've got a job, we better show up. get to the course at 9 o'clock in the morning. Personality, family history, intelligence, addiction, all kinds of things there in the middle. And then on the right-hand side, we do have some severe pathologies. Severe depression. Do people have free will in severe depression? Not much. Not much. Severe constraint and so forth. So, you know, there's a spectrum, isn't there? So free will is not just one, or you have it or you don't somehow. You know, it's on this great long spectrum. It's not an all or nothing phenomenon. And it's an operation of the mind, which we're going to talk about later this morning, I think. So I'm going to skip the mind. But okay, just to, you know, for the sake of time and so forth. I just want to reflect a little bit on the causal nature of the genetic variants. Because you often read, still even to the present day, some report, you know, people have discovered a gene for happiness or a gene for whatever it is, you know. So I want to highlight the point that variant genes are difference makers. They do make a difference. But they make their difference to a large degree in our lives through all that molecular machinery of the brain during development, all that early fetal development, all that early postnatal development, all the way through childhood, and all the way to the decisions we make every day. And so you see, therefore, differences in emergent properties of the physical human person that emerges from all that process. Okay? So they're difference makers in that sense. They can give us predispositions to do certain things. We can vary in our personality. Certainly, genes are involved in the development of different personalities, and clearly that's going to have some influence on our lives and so forth. So that's a sort of causal role I want to put before you for different genes. So definitely it's not a question of gene X encodes for behavior Y. That does not exist. Right? There is no gay gene, by the way, just on that point. Okay? Just let's get that clear, despite what's written on the back of some T-shirts and so forth. Although genetic variation might well be involved, don't get me wrong. Okay, but I just want to get away from this language of a gene for that sort of thing. So the sliding scale of genetic influence, yeah, as I say, on the left there is no heritability for what languages we learn, what university we go to, what religion we chose. There's a zero heritability, right? But if you move along that spectrum towards the right, then you see the heritability level is going up. Okay, and yeah, so clearly we have free choice over many traits that have a positive heritability. So I'm going to move on now because I've just been given the 5-minute warning here, which is good. And I want to just give you conclusions on genetics, and let's give you a little bit of theology at the end. So I want to make the claim this morning that there's nothing in genetics that falsifies the reality of free will, with the exception of those genetic variants which cause major pathology, and there are some. And so I would want to go further than that, actually, and say it's because we have our particular human genome, and that's what renders free will possible. That's what makes us humans. And having free will is just a trait that all humans have. Okay. And we can come back to that in the discussion time. Okay. Now I want to just reflect a little bit theologically in the last few minutes. Okay. So we've already talked about humankind being made in the image of God over the past few days, I know. And I want to spend a bit more time on this as well, because I think that imago Dei, that sense of humankind being made in the image of God, is a very important bridge, if you like, between theological narratives and genetic narratives about humankind. And so that's where I want to go. And this idea, of course, of the humankind being made in the image of God, as you know, has a very long history. It's been very powerful, actually, as an idea in shaping moral values, in shaping political systems, medical care, education, justification for human rights. It's a very, very powerful. You go back to the abolition of slavery and look at the role of the concept of humankind made in the image of God in that great campaign to abolish slavery. It's a very, very powerful idea. But I want us to go back just for a second and just go back to sort of the Ernest Lucas approach to the early chapters of Genesis. Think a little bit about what we really understand by that term, or what they might have understood by that term back in when at Genesis text was first being read by people. There are only 3 mentions of the term image of God in the early chapters of Genesis. This is the first one, let us make humankind Adam in our image in Genesis chapter 1, that rule over the fish of the sea and so forth. So God created Adam, humankind, in his own image. In the image of God, he created him, male and female. He created them. This is clearly about the creation of humankind. Now, the question is, if you were a reader in the Near East at that time, reading that, what would you have understood by the term image of God? And it's interesting that the image of God language is used all over the place in Egyptian literature, and also a little bit, somewhat, in Mesopotamian literature as well, and the languages of that time, to refer to kings and priests. Kings and priests were called made in the image of God. So it's a privileged few, it's an elite aristocracy who were called the people made in the image of God. So now, we miss this, certainly in Genesis 1. It's revolutionary. This is political. Okay, this is political dynamite, right? Let's be clear. Because now the term image of God is being democratized. It's being applied to the whole of humanity. It's no longer just the privileged few who have that wonderful role to play and so forth. So I think we kind of can miss that. We can easily miss that, can't we, in terms of we don't read in that way. We're not in the same cultural context. But there's been a lot of writing by wonderful theologians on that particular point over these past few years. And there are two particular points I want to highlight here, which bring the image of God concept into conversation with genetics. The first is this value and status, therefore, of each human individual, irrespective of their genetic status. So the whole of humanity is made in the image of God. And some people can practice that more than others. But what it's saying is, independent of your educational background, your genetic inheritance, your family, your race, your color, whatever it is, we're all on the same level playing field. We're all made in the image of God. And that's incredibly important, I think, when it comes to this discussion about genetics, because it means that it undermines any attempt to use genetics to put one class above another, or to claim that some people have privileged genes because, they can do other things better than others and so forth. So it's a great leveler in that fact. So the fact of humankind being made in God's image subverts any move to make distinctions between people based on their genetic endowment. That's the take-home message there. Secondly, I think there's a strong message here about diversity, male and female. He created them. And I think Ernest Lucas was bringing this out very clearly as well. And so it argues in favor of the wonderful genetic diversity that we do in fact see around the world population. Some people see that as a threat. No, I think it's wonderful. It's great. If we didn't have genetic diversity, we'd be looking like a clone in this room this morning. That'd be so boring, okay? We're all a bit different. We all got different personalities. We all got different backgrounds. That's wonderful. And that's what I think is underlying also this wonderful delegation of this task of helping subdue the earth, to care for the earth, look after the earth. We'll be thinking more about that tomorrow. But diversity is in the mix there. And there's enough diversity in our own genome, in our own DNA, to guarantee that every single person that ever lived, including every single person who ever will live, is going to be slightly different. It's going to be different. Okay, it's amazing. Isn't that amazing? We're all going to be different. So even identical twins. Remember, identical twins are not really identical. We can come back to that. Okay. Epigenetic, right? They're epigenetically quite different. Okay, that's another story. But anyway, so what I want to say here in closing is consistent with, I think this whole idea of diversity is consistent with the human diversity generated by human genetics plus diversity. In other words, the genetic story here, I think, is very consistent with the theological story. Right, conclusion. There's nothing in contemporary genetics, barring some rare but tragic cases of medical genetic pathologies, that in any way subverts personal moral responsibility. Variant genes are difference makers that, in the context of behavioral genetics, can influence our wants, desires, and predispositions, but responsibility for actions remains with us as personal agents. And this portrayal of personhood provided by biology is certainly consistent with the theological idea of humankind made in the image of God, with a highlighting of individual value and emphasis on diversity and in community. So with those thoughts, I'll finish. Thank you very much for your attention. As Keith said, I will obviously plug the book. And if you want the detail of that, Genes, Determinism, God is where you'll find it. Thank you.
Thank you very much. I think we left about 30 minutes for the discussion. So, obviously, one hand drawn up straight away. Wait for the microphone to come to you.
Yeah. Okay. And thank you for giving us another view like yes, DICI, yes, instead of the nature-nurture dichotomy, and that's inspiring and good. But I guess as a Chinese, some points of the discussion about the Darwin say free will is genetically embedded in every human. And because I experience free will experience, but I guess not many Chinese people experience free will. And if you say this is genetically embedded, I think as a Chinese ear, they will feel like question about am I a human if I have no free will experience or experience freedom. And as a theologian, I guess I would say that the free will is a gift of God, and actually is the history Enlightenment period of the European history enhance and confirm and generalize the free will of every people. This is what I feel like, and I just want to express. My question is it any scientific evidence that can show the free will is related to some genes, and these some genes are correlate with free wills that every human being have?
Okay, so my first point would simply be to say I'm certainly not going to talk about politics in this context. Okay, we don't talk about politics in the Faraday Summer course because we all come from many, many different countries. So I want to emphasize that. Having said that, obviously, when we express our free will in different ways, we are all constrained in various ways in all of our countries. And I have to say, you know, I can speak for my own country anyway. We're heavily constrained often by fake news, by the media pressure. Young people are constrained by social media very strongly. If you go to young kids, if I go to my grandchildren down the road here in the school, you know, starting now to get into social media, Twitter, and all the rest of it, Facebook, there's a lot of pressure there about their free will. Okay. In other words, the point I'm making here is I think that all of us who live in any kind of society obviously are constrained in various ways in the expression of our free will. None of us have total freedom on the planet Earth, right? So that's just a general point to make. Having said that, at the same time, we are all, you know, we all experience freedom to get up in the morning. We can choose what we have for our breakfast. We can choose whether we want to go to, you know, do this today or go on holiday, or some of us can choose who to get married to, you know, other cultures it's chosen for us, okay, so it does vary a bit. So we all have this range, don't we, of choices, but they're all constrained in various ways, okay. Now to come to your second point there, are there any sort of genes for free will as such? No, not genes for. So the genome gives us a wonderful resource of information, which is then used, as we've been discussing, during development to generate human individuals, right? And so I just summarized very briefly a very long story. Okay, it's a very long and complex story, but so we all end up, you know, as humans who are, we can self-identify as part of Homo sapiens sapiens. We can breed with anybody else in the planet, in principle, and the other humans, and so forth. So we're all part of the same human species in that sense, anatomically modern humans. And all anatomically modern humans all have the same genome, not the same identical, but very, very similar enough so that individuals can have fruitful sexual reproduction. That's the biological way of looking at it. Okay, so therefore, so our free will is a product, if you like, of our big brains, of our big frontal cortices. I mentioned the number of synaptic connections that we have in our brains, a huge computing power. If you want to get a computer to even mimic what a mouse brain does, even 1 centimeter of mouse brain, you are going to be days and days on the largest computers in the world. Okay? It is extraordinary, the amount of computing power, even in a small animal's brain, let alone our big brains. Okay? So mimicking the function of our brains in computing power, I actually have some hope for quantum computing in that direction. That's another discussion. Okay? But in other words, and it's that huge computing power, I think, which underlies our consciousness, which of course we don't understand. We don't understand. We don't know how to translate I language into it language, the language of my personal mind. We don't know how to translate that into brain language or vice versa. Little bit's coming, but not very much, and so forth. So in other words, I want to say that free will is the, if you like, the characteristic of the human individual. It's the characteristic of the human person. And the brain, definitely, you need that to help you do that, okay? But it's a human person in interaction with their environment, with other people. So the mind will always in interaction with other people and so forth. And so there's no gene, there's no gene for free will. But if we didn't have a human genome, then it's quite possible we wouldn't have free will. And that then raises another question, which will probably come anyway, as to, do animals have free will and so forth? Okay, a simple question, isn't it? But let me make one point here that animals clearly choose. All animals are making choice. When I looked at my cat this morning, okay, when it came in, it was definitely making a choice, about what he wanted for breakfast and what that cat wanted me to do now, right now. Okay, there are certain techniques to bring that about. Okay, the cat is making a choice. Does my cat have free will? It's hard to ask an animal, isn't it? Because free will is an experience which I think you have because we can talk to each other, and therefore we have the same experience. We have the same mind, so I can communicate my experience of free will to you, and you can tell me about yours. So, but we can't do that with the cat. The cat can't tell me. So the discussion doesn't arise amongst animals in that way.
Hello, thank you for your talk today, very enjoyable. My question is quite a simple one. Can you explain your understanding of the term made in the image of God? I'm assuming you're not assuming that God has genes, genetics and cells and a body. I'm not sure.
Right. Sorry, I did move quite fast to the use of that phrase. So what I think is important for us, and this is touching also on Ernest Lucas's talk on Tuesday, is to seek to interpret texts of the Bible within their context, their historical context. And so if we come across a phrase like we do in Genesis 1, made in the image of God, our first challenge is to find out what it means. What did it mean for the first readers? Okay. Now, there is a book, by the way, I'd like to recommend by Richard Middleton called The Liberating Image. There's a whole book. If you don't know that book, it's a very good book, actually, on the meaning of the image of God phrase in its historical context, and so on, a very thorough book. And as Richard and many others have pointed out, as I was saying, in the context of the time, in the languages around the Jewish people, in the languages of Egypt and Mesopotamian languages, when you come across that phrase, image of God, it's used of priests on some occasions and of kings. It's used to describe them in honorable terms. It's an honorable description of kings and priests. Bow down, aristocracy, be careful, be nice to them, right? They're ruling over my lives. Remembering, of course, that the bulk of people were serfs. They were working on the land and so forth. They were not aristocrats. They were not the leaders of their different cultures and so on. So now, Genesis 1 is saying, humankind, male and female, he created them. Humankind is made in the image of God. So what immediately will come to their minds, that means all humans have this wonderful privileged status in the sight of this one true God that Genesis 1 is talking about. Okay, so remember they've got polytheistic cultures all around them. And the main point, isn't it, or the first main point about Genesis 1, no, there's one God who does everything. On day 1, day 2, day 3, there's one God, monotheism. You have there the sort of strong declaration of monotheism. And then dramatically, it's saying humans are made in the image of this God. And okay, so God is delegating to humankind responsibilities to care for the earth. That's what it says in the text. To look after the earth, to care for it, to have this privileged status of being made in his image. It's nothing to do, I mean, some people have discussed physicality and so on, but it's not about, we're not physically made in the image of God in that sense. It's not a physical relationship so much as responsibility, delegation, value, and mission, giving humankind a new mission to really care for the earth and look after it. Does that help a little bit? It's a non-physical, I wouldn't say theological really. Genesis 1 is a theological essay. Right? So that's how I would call it. And theological essay, you have to understand it in theological terms. So. Yes.
Using the word image suggests image rather than position or authority.
Yes. Well, okay, we can talk about more if you like, but yeah. It is there's a lot of literature about the whole thing, by the way. Yeah. So.
I had you with big pleasure. Thanks, Professor. And my question is, what you think about genetic improvement of man in modern stage, and what you said, what you will say about morality of these questions?
Yes. Well, fortunately, I've just written a paper about that. Okay, which should be out in the next few days. Now, what on earth did I call it? Genes, God, and the Future of Humanity, or something. And it's a Cambridge paper. If you Google Cambridge papers, you will find they're all free online. And I don't think it's been posted yet. Anyway, yeah. So, but to come to a summary of that, I mean, it's a big topic right now, clearly, called enhancement. Should we use genetic engineering for enhancement? And the discussion has been much stimulated by CRISPR-Cas, which is the genetic engineering technique which came about a few years ago, which has now taken over the whole world of genetic engineering. And it's been stimulated even further by the announcement in November last year by a Chinese gentleman that he had genetically engineered, he had removed a gene from a pair of twins in China in order to help them to be more resistant to the HIV virus. Okay. So for the very first time, we now have a case which is not yet published, but probably has happened, where a particular gene has been removed from the human genome in, turns out, one of the pair of twins, actually. I don't think it worked in the other pair as far as I understand it, but it hasn't been published yet. Okay. So that is now, of course, stimulated, again, quite a big discussion about enhancement. And then the discussion, next step is, well, what do we mean by enhancement? Okay. I'm not going to ask questions here, but I bet some people here are taking statins, to bring down their, to help them give protection against cardiovascular disease. Well, I'm wearing glasses. So, oh, yes, I'm definitely enhanced as I put my glasses on. Oh, I can see you now. You see, so I'm enhanced, aren't I? Or is it a correction? Or is it just healing? Is that healing? Okay, so there are some things, where it's not totally clear. There's some athletes who are disabled, but who have some wonderful machinery to help them run pretty fast. Okay? And you could argue that it's not really enhancement because they're simply getting up to the range of speed that you can find in general human populations. Okay? So the definition of enhancement is tricky, right? But having said that now, if you want to talk about genetic enhancement, most people say, well, actually, all the things, you find out in the transhumanist literature or in sci-fi, films and stuff, is a bit naive. And the reason it's naive is because we know that from lots and lots of studies recently now that the variation in education attainment that you see in a population, which does have a positive heritability, so genetics has something to do with that. But when you start looking for the numbers of genetic variants involved, there are hundreds and hundreds, okay, possibly thousands. And that's what you would expect, because after all, at least 50% of our genes are involved in making our brains, okay? So, and we have 20,500 protein encoding genes, something like that. So you know, probably at least 10,000 genes are involved in building brains, okay, during fetal development and so forth. And so it'd be very understandable if there are thousands of genetic variants that make a little bit of difference, you know, to the way we use our brains. Some people have greater emotional intelligence. Some people have greater analytical intelligence, and their emotional intelligence is not very high, okay? I can speak from someone who's been in the scientific community for a long time, okay? Anyway, I won't go there. You know, so we all vary in that way. So then you come to your question, which is, well, how can we, how should we enhance the intelligence of individuals? Oh, wait a minute, how are you going to do that? We're talking here about thousands, okay? Now, there are some companies in the States already who are starting to promise, you know, we will do embryo selection and we will select out embryos, you know, that are likely to be more intelligent than others. And they're kind of forgetting that all the stuff about these genetic variants is population statistics. It's not about individuals, okay? So it's still the best way, if you want your children to be, you know, have a good education, well, get them reading, looking after things, drag them away from the television a bit more. You know, a lot of environmental things one can do to help kids. And I just don't think genetic, I mean, the genome is its own best defense against meddlers, as I often say. In other words, it's so complicated that to think you're going to improve intelligence. And anyway, would you want to improve intelligence by genetic enhancement? I can't see the point. I mean, we already have enough separation between people. So would you want some elite class, you know, got special genes that give them greater intelligence? And what kind of intelligence would it be? When we look at the wars, look at the history of wars, they've been run often by very intelligent people. Do we want more intelligent people to make bigger wars? Is that what we want? Okay. So there's a big discussion there, which is fascinating, but I better stop, because I'll get carried away.
Just a question in relation to the image of God again, and I was probably quite a sensitive question, but I was just wondering, what was your thoughts on, oh, well, yes, we're all human and we all have the same phenotypical appearances, but in terms of cultural and ethnic differences, in terms of skin color and hair type and those types of things, what was your take on that? Oh,
I just think it's wonderful. I think it's all part of the wonderful variety that we have in the world. I mean, you know, it's just, I think it's great. You know, I mean, my son decided to have dreadlocks. Well, it wasn't genetically inherited, but, you know. And I said, it's fine, you know. And he had dreadlocks for a couple of years and then decided, you know, he moved on. Teenagers did. I mean, you know, everyone does. So I think it's great. I mean, but, you know, all this, that's what I mean. I think the genetic variation that we have in the world, it generates all these different, you know, different things about us. I mean, clearly, the differences about us in terms, if you really want to measure up the differences between us all in this room, the biggest differences are not what you see in our face or hair or things. Actually, they're not the biggest differences. Look at the heart. If you really want to, look at your brain, look at heart, look at your kidneys. You know, so lots of differences around. It's just we don't see them, you know, we don't see them, do we? Muscles, you know, we're all very different in every single aspect. All these variations are going on. But we tend to, unfortunately, I think sometimes unfortunately, tend to focus on some difference in skin color or difference in something like that, simply because it's more visible. But actually, if you want to add up the really big differences, they're inside us. It's just there. We don't normally go around saying, oh, your kidney looks, twice as big as mine. I'm jealous. Okay, we don't normally do that. Okay. So, yeah, I think we should, as a Christian, I'm thankful for the variety of we see in the world. I lived in the Middle East, by the way, 15 years. So I'm quite used to living as a very small minority in a very big population of people who think very differently from me. It's fascinating. I think we should, you know, we should enjoy different cultures and enjoy different ways of doing it. Anyway, that's where I'm coming from.
Thank you for that. I found it very interesting. I think, as I understand it, the free will argument isn't on the level of choice or decision making per se. It's on the level of, it's on a meta level, on the level of all the factors that bring to bear on which genes are expressed and are inherited. And it's an age-old problem that it predates current science. It's brilliantly wrestled with in Oedipus, and how it seems that Oedipus makes decisions, and yet fate determines his ultimate destination. And that's where the deterministic argument lays, as I see it. So it's almost as if free will is subsumed into this matrix of determinism. I wonder how you might respond to that.
Right. Well, clearly, if you go to the philosophical literature, as you will know, about free will and determinism, there are certain categories laid out. Either you're a libertarian or you're a compatibilist. There's subsets of those. There are different ways of interpreting each one. And books and books and books. I have a shelf of hundreds of books on that, actually. And I haven't even read all of them yet. So, I have to say one thing I do find, and again, I'm coming to this discussion, I'm not a philosopher. I come to it, I've read a bit of philosophy and I read these books and so on. I often find they're not all that helpful sometimes, because once you get labeled, some people say, oh, you're a determinist. And I put in my side, I don't think so. No, I believe in a genuine free will, and we can really choose things, and that's and then, of course, the language of compatibilism. Compatibilism is defined as people who say, well, your sense of free will is compatible with an understanding of the normal workings of the brain, gnomic regularity, the normal function of neurons, and so on. So I'm more, in that sense, I'm more in the compatibilist direction. But even having said that, I find some of the definitions of compatibilists are not where I'm coming from, and so on. So it does get a little bit complicated, doesn't it? Well, I have to say that what I find quite helpful, and I'm speaking here as the scientist, is saying, well, look, here we all have this experience of free will. How, free choice, we can define it in various ways, but generally speaking, we all have that experience. And, as we've been talking about earlier on, there are different levels of constraint. But we all have it. We can all choose what we have for breakfast, probably, hopefully, unless we're in a situation of starvation. Again, some people, constraint. But having accepted that, so my question then is a little different. My question is there anything in genetics or brain science or biology that would undermine my sense of free will? What can I come up with? Now, in fact, in neurology, there are some well-known claims about that. The lipid experiments. We haven't even touched on those because that's, I think, a topic more of the brain stuff later on today. The lipid experiments claim that undermines free will. If you don't know what those are, we have a Faraday paper by Peter Clark on that, which is a very good paper, and so on, and lots of writings. I think generally speaking now, there have been so much writings from different philosophers. They don't think lipid experiments really undermine that sense. So I think that's a way of setting up the discussion, which we can do some work on. We can say, well, what will undermine that understanding of free will? I can't see anything yet that has done that for me, anyway. So.
Thanks. Hi, again, thanks for the talk. I just wanted to ask, where do you think the limit is for this discussion in terms of free will seeming in terms of personal agency, not necessarily like where you end up, as being important to be able to choose to enter into a relationship with God or not, as a Christian, and how when Paul writes in the New Testament epistles, I don't think he's aware of the sort of limit cases that involve like monoamine oxidase variations. And do you see some sort of hard limit where we can't know about some of these things?
Sure. I haven't touched at all, I don't think this morning, on the long, centuries-long discussion, about predestination, free will, all that theological discussion, which keeps plenty of Christians having lovely talks together with each other. And, which is also then Islamic theology as well. It's not just, so although it comes in different contexts. So, excuse me. So, I'm not touching on that at all. But I would want to say, that whatever one's views on that discussion, we don't have time to get into that, I don't think right now, but whatever one's views on that, I think everybody, every Christian and everybody else would say, well, if you ask anybody, whatever their views, do you have an experience of going to church on Sunday, Did you choose to go to church on Sunday? Did you choose to open your Bible and pray this morning? I think most Christians, whatever their views on predestination, would say, yeah, absolutely I did. Or I didn't. I should have done. Okay? And so I think there's a sort of unity about the general understanding of our daily practice of free will. But that leaves aside, the whole question of predestination and free will, which possibly we could leave to another day. I don't know.
In fact, what I'd actually very briefly ask you to do is go back to one of the topic you were talking about earlier, when you talked about the editing of the child's genes that had happened in China. Yes. That is something that many of us would find very difficult to countenance. But turn the question around the other way. If you have a small child, or an embryo perhaps, which has the Huntington's gene, single gene edit situation which produces a terrible disease later in life, known to kill, known to produce early dementia and so on. That would be perhaps par excellence a case where it would be potentially very beneficial and therapeutic to intervene with the human germline. That's the sort of case that's quoted for that. Now, if one assumes that will probably happen at some point in the not far distant future, something similar to that, where do you see it going from there? Because what one can see is that might then gradually open up into the more uncertain. Can I ask you to, if you could, speculate, if you wish to, a little about what might happen in those circumstances?
That's right. Thank you very much. A very pertinent question. And that I do address that question a little bit in the, in the Cambridge paper I mentioned earlier, which is clearly an issue. So I guess one of the first things to say is that, there is pre-implantation diagnosis already available. It's certainly, there are more than 200 genetic disorders in this country where you can get pre-implantation diagnosis. If you don't know what that means, it simply means you have an in vitro fertilization clinic, IVF clinic, and you've got two parents who have a family history of a particular genetic disease. And so in most, 99% of the cases, you can screen the embryos, and there will be at least one, we hope, that will not be a carrier of the genetic defect that's going to cause the disease. It depends if it's, it depends if it's sort of a recessive or dominant gene and various things like that. We won't go in there, but in most cases you can do pre-implantation diagnosis for some of the really horrible lethal diseases that you're going to die from or whatever. Okay, that's already available. So the pragmatic question is, well, why don't we just make that system work better? Okay, so that's one of the pragmatic arguments in this whole discussion. It's already there. People are using it. It's a way you get to the same outcome. The outcome is, the outcome is that you have a child without that disease. So the outcome is the same. Now, of course, then, people who want to carry on doing the, embryo editing for human disease will say, yeah, but there's this particular case, where both the parents have carrying the Huntington's disease gene, or some dominant gene, and you won't get any embryos that, so you can really make up those stories. But the number's actually a tiny, very small percentage will really be in that category. Actually, I was talking to, are we on camera? I don't think you mind me saying this. Anyway, I was chatting with Francis Collins about this a few months ago, and he was just saying, pre-implantation diagnosis, why would you want to go to this very expensive and potentially dangerous modification of the human genome by embryo editing, generating all that technology? Why would you want to do that when you have pre-implantation diagnosis? So I think that would be my first answer. Now, I think you're right, though, that there will be a strong pressure, probably, to heal human embryos in the way that you suggested, because some scientists always want to be the first to do that, and so there will be pressure in that direction. I think I can see the arguments on both sides. Would Jesus heal human embryos? Discuss, okay? Coffee time discussion, but yeah, exactly. So, but I mean, the question then would be, as you hinted, I think if you get all the technology to do a good job safely, which is not with us yet, but if you get, and that will come, I'm sure it will come. If you get to that point where it can be really safe and so forth and so on, yeah, then what else could it be used for, in terms of manipulating human genomes, and the potential for evil uses as well as for good uses, I think it's quite high. So I'm not, it's just an ongoing discussion. And a lot of ethics committees around the world now are discussing exactly that sort of point, actually. It's a big discussion. If you read Nature, you'll see it every week in Nature, pretty much. There's some, and Science and journals like that, you'll see discussions going on about this sort of thing, actually.